Welcome to qnawire.
Okay, our question says, what was the average velocity of the particle in problem 17 between t equals 1 second and t equals 3 seconds? And then it says, what is the magnitude of the instantaneous velocity at t equals 2 seconds? So I wrote what we were given here. We're given the particle in problem 17, which is represented as the vector r of t, which is 9.60 times t in the I hat plus 88.5 j hat minus the times squared k hat. So then we want to find the average velocity between t1, which is 1 second, and t2, that's an S. t2 is equal to 3 seconds. Okay, so the average velocity, which will, let's scoot that up just a little bit, which we'll write as V average, is a vector that is represented as is calculated as R of T2 minus R of T1 divided by T2 minus T1. Okay, let's go ahead and calculate that. Well, R of T2, we're just going to plug in the values for T2 into R of T. So the first one is 9.60 times T2, which is 3. So 9.60 times 3, which is 28.8. So we have 28.8, and that is in the I hat direction. Okay, plus 88.5 in the j hat direction, since j has no t dependence, minus t squared, t being 3, 3 squared is 9. So minus 9.00, and that's in the k hat direction. Okay, so that's R of T2. Now we need to subtract that. Subtract from that R of T1. T1's 1, so 9.60 times 1 is just 9.60. That's I hat. Plus 88.5, no t dependence. J hat. Minus, well, we have t squared. T squared is 1, so minus 1 k hat. Okay, and that's going to be divided by T2 minus T1, so 3 minus 1, which is 2. Okay, and the units on this are going to be meters per second because this is velocity. Okay, so now if you go ahead and carry out the calculation, you take 28.8, remember this is important, that you can only add and subtract like components. So the I components, J components, and K components can be added and subtracted, but you can't add and subtract IJ, JK, IK, for instance. Okay, so 28.8 I hat minus 9.6 I hat divided by 2. Okay, that gives you 9.6. And that's I hat. Okay, then you have 88.5 J hat minus 88.5 j hat divided by 2. That's 0. So we have no j hat component. We don't need to write it. Okay. Then finally, you have minus 9.0 k hat minus 1 k hat. So that's 9.0 k hat plus 1 k hat divided by 2. That's minus 4.0 k hat. Okay. Oh, also, one thing, we need to remember to use our significant figures, which is 3. So I need to write 9.60 here, not 9.6. And that is in the I hat direction. Okay, box that in as our solution for the average velocity between T2 and T1. Next, we are asked to calculate the instantaneous velocity at time t equals 2. Well, we can calculate, or I'm sorry, we're asked to calculate the magnitude of the instantaneous velocity. So first we need to find the instantaneous velocity, which is just the time derivative of r that we're given for our particle. Okay, so we're going to take the time derivative of 9.60 t I hat plus 88.5 j hat minus t squared k hat. So we're going to take the time derivative of each one individually, and we'll just work through that. So the first one is 9.60 t for I hat. 9.60 t time derivative is just 9.60. And that is the I hat direction. Okay. 88.5 has no time component, so that's just going to be 0. So we don't need to include the j hat direction. And then finally, k hat. So minus t squared. So we're going to end up with the minus sign here. The time derivative of negative t squared is negative 2 t. 2 comes down front, subtract 1 from the exponent, you get minus 2t, and that's in the k hat direction. Now, we want to know it when t is equal to 2. I'm not 20, 2.00 seconds. Okay, so we'll plug that in for our equation, and we get v is equal to still 9.60 because there's now no time dependence on the I hat, so nothing happens there, minus 2 times 2, which is 4, so minus 4.00 k hat. Okay, now to find the magnitude of v, we take the square root of the sum of the squares of the components that make up v. So 9.60 squared plus minus 4.00 squared. Let's extend that square root because it covers everything. Okay, and if you carry that out, you will find that equals 10.4. And the units on that are meters per second because, again, velocity. Box it in as our solution.